Hello students, today we will discuss about the time domain analysis of first order RL circuit or RC circuit, both RL and RC. Now first RL circuit. First we will look into time domain analysis. First thing is, what is time domain analysis? Time domain analysis means a simple thing by varying the time from 0 to some infinite value, how the variables are varied, how the variables, that it may be current or voltage. What is the change in current or voltage is nothing but the time domain analysis, simply. So by varying the time, how the current or voltages or power or something, anything that can be analyzed, that can be observed, is nothing but the time domain analysis. For he particularly mentioned for only first order circuit, RL circuit. First order, what is first order? Before that, first look into our passive element, resistor, inductor, capacitor. So you know that resistor in electrical circuit, in electrical system, always absorbs the energy. It will observe the complete energy. That's why it is the energy dissipating element. Energy dissipating element. And inductor, capacitor, you know that those are energy storing elements. They will store the energy. Inductor and capacitor will store the energy. Here first order means one energy dissipating element and one energy storing element combination is known as first order. First order means having one energy storage element. In a circuit, one energy storing element, maybe inductor or maybe capacitor. If it has the one inductor, it is a first order system. If it has a two inductors, second order system. Or if it has a one capacitor, it is a first order system. If it has two capacitors, it is a second order system. If it has the inductor and capacitor combination, automatically second order system, like that. So that's why RL, RC are the first order he mentioned. Combination of one energy dissipating and one energy storing element is the first order system. Look at here RLC, one energy storing element, one energy dissipating element is the R. Inductor and capacitors are the two energy storing elements. That's why two elements are there. Here 2 is there, that's why it's second order system. Here 1 is there, 1 is there, that's why it is the first order system. Understand? So in this we will discuss about first order system only, right? So once again we will justify the title here. Analysis of the responses of a circuit. Thus analyzing the responses. Responses means output of a circuit consisting of RLC. The circuit is combination of resistor, inductor and capacitor and sources. Sources means we have voltage sources and current sources. That means a circuit consisting of passive element with the sources and switches. The circuit also consisting the switches. Switch means if you on the switch, the circuit current will passes. If you off the switch, current will stop. To sudden application of voltage and current is called time domain analysis. For any circuit, if you suddenly apply the voltage or current, how that according to the time, how the current and voltages are varied will be discussed in the time domain analysis. That's why I mentioned here, by varying the time for that circuit, by varying the time from 0 to particular value, how the current and voltage values is varied is observed in the time domain analysis. Time domain means we are observing the time, analyzing means analyzing the whichever will be possible, which are the responses. Responses in circuit simply it consisting of the current and voltages. Understand? Current and voltages. So this is about the time domain analysis. First order means consisting of one energy storage elements and one energy dissipating elements. Second order means it has two energy storage elements. Okay. So this is about the time domain analysis. Here First point, first thing is a series RL circuit. We will discuss time domain analysis in the series RL circuit. Look at here. So, it consisting of the series RL circuit, it is simply a first order system. So, that is why I am taking the RL connected in series and I taken a switch to on or off the circuit and I will supply the source. That means, source will supply the power to the resistor and inductor elements, right. So, now we will analyze with respect to time how current and voltages are varied. We will discuss regarding inductor actually. This is our output terminal, you can observe from here, right. So, assume that switch is closed at t equal to 0, at particular t equal to 0 time is closed, that means it start from time equal to 0. So, we have to apply the KVL. So, that means it will be closed at t equal to 0, at t equals to 0, right. So, if you observe here, now the circuit is the closed path, now the circuit is the closed path. Whenever the circuit is closed path is there, directly we can apply the KVL, by KVL, apply the KVL minus Vs and it will flow some current, the flowing current take it as I of t. Why we are taking, generally the current will take I, but we are considering the small t represents time domain analysis, how the time varies represents, that is why I of t. So, voltage of the source is minus Vs and this is the closed path, voltage across resistor is I of t into R into I of t, and the voltage across inductor directly formula L into di by dt, but in place of I we will get I of t equal to 0. So, by applying the KVL we will get this equation, by applying the KVL. But what is our requirement? Our requirement is to find out the current, flowing through the circuit or current flowing through the inductor, and to find out the voltage across the inductor. By observing these two things, with respect to time, then our analyzing will be completed. What is our requirement? Our requirement is to find out the current here. So, if you observe this equation according to the mathematics, this is the non-homogeneous linear differential equations. Non-homogeneous means the degree of the terms is different and it is a linear differential equation. Generally, it is a linear differential equations. Particular mathematical equations, the solution, that means to find out the current from this equation, solution is two types. So, to find I of t, it has two solutions. One is complementary function, another one is particular integral. One is complementary function and second one is the particular integral. So, by finding these two things, our solution will be completed. That means our required current we will find out. So, this is regarding to the mathematics. So, for that, the first case, complementary function. In order to do the complementary function, simply we have to remove the source. That means from this equation we can write like this. The equation is, we can write the modified equation, take it as a first equation, assume it is the first equation. From this we can write source voltage is, it become outside, it become plus, the remaining terms are R into I of t plus L into di of t by dt equals to 0, equals to 0. So, complementary function is done by, we will get the complementary function, that means complementary function means I of t for complementary solution generally. IC of t, to get IC of t, source must be 0. Source must be 0. Whenever we are equating the source is 0, then we will get this complementary function. So that's why this will be become 0. Then the equation is modified. The equation is modified. This is from equation 1. From equation 1. So for that we are removing this equate to 0. That's why it becomes 0. The remaining term r into I of t plus L into di of t is like this, right? Here by dividing all the terms with L, then L will cancel, will get 1 here, and by this function r by L here into I of t is equals to 0. I of t is equal to 0. So by mathematical calculation, by solving the above equation, we will get IC of t equal to some constant into e power minus r by L into t, r by L into c. This is only IC of t, means complementary function. In the solution we will get one thing, complementary. C means the complementary. We will get k into e power minus r by L into t, r by L into t. Just only one particular function will be completed. One particular function will be completed, right? In this, we will learn one new term regarding our circuits. The new term is called time constant. The new term is called time constant. It is represents with tau. The name is tau, right? So tau symbol is like that. It is like a T, but T has some curve. It has some curve, right? Time, tau means, the definition of the tau is, it is the time required to reach the 67% of its final steady state value. Generally, when we close the switch, it will not reach the final steady state value, final DC value. It will take some time. But in the process, in order to reach the final steady state value, at particular value, it will reach 67%. At which time the required quantity will reach the 67%, the time is called the time constant. The time is called the time constant. And I will clearly explain what is final steady state value and what is 67%. I will clearly explain. Just keep in your mind, and after the completion of this, you will clearly understand, right? But to reach final steady state value is t equal 5 into tau. T equal 5 into tau. After 5 time constant, the quantity will be reach the final steady state value. That's why for series RL circuit, generally tau value is generally L by R. Tau value is L by R. By substituting this tau value in this equation, the complementary function is become like this. IC of t equal to k into minus e power minus t is up, become down. This is the first is completed. This is the first equation. This is the complementary function. This is the third equation. This is just we completed only complementary function. Complementary function means simply equating to 0, finding some value, but we will find out the new term. The term is the time constant. About the time constant I will explain later, and just finally the equation is become like this. This is about the complementary function. Now the second thing, particular integral. So first thing is completed, complementary function is completed. Now we will discuss second part, particular integral. Particular integral is nothing but directly give the steady state value. If steady state value means the value is constant, no change of its value. That means generally generally, so any current or voltage, it has transient values and steady state values. So, the difference between transient and steady state is like this. When the switch is suddenly on, suppose in a circuit the 5 amps current will be flowing if it is consisting of the inductor. It directly does not reach the 5 amps. It will take some time to reach 5 amps. And after some time it will be constant. The value is constant. So, generally we are doing directly problems on this area. Directly it will take is the constant. So, this area is called it as this region. It will take some time. This region is called as transient region. Transient. Before steady state region starts from 0, transient region. After that it will fix value, that region is steady state. Steady state means fix. It will reach the fixed state. After that its value is fixed. So, now we are doing up to this area represents complementary function. This area represents particular function, right? Particular function. That is why we are doing the equation for this area. Now, we will discuss clearly about that value, but just keep in your mind. For that steady state value, at the steady state value, the current, we are discussing about the current flowing in the circuit, the current is constant. Whenever the constant value is there, when we are differentiating with respect to time, automatically that value is 0. If you differentiate with constant value, that value is 0. This is one point. For particular integral, we are considering the getting from the first equation, Vs equal to R into I of t is become a steady state value. That steady state value, fixed value, last value is, maximum value is I of I. Here I you can take like this, I is max value, I is like this, I is maximum value or steady state value. It is the maximum value. Before that it will not reach. It will not reach that value. That will we can call maximum value or steady state value. Right? Yes. So that's why it becomes 0. From that I equal to Vs by R. All inductive terms are become 0. We will remain finally I equal to Vs by R. I equal Vs by R. When it reach this value I equal to Vs by R. Right? This is the solution. So, finally, we will get two solutions. So, that is why we can call it as particular current, or we can name it as particular solution I, or we can name it as I particular of time constant. I particular of time constant. Simply, that is why the time at particular solution. That is why the complementary solution, not complementary, this is complete solution actually, not complementary solution, this is complete solution. Complete solution meaning is, it is a combination of complementary solution as well as steady state solution. Complementary solution, from the first solution we will get k into e power minus t by tau. For particular solution and steady state solution, E equal to Vs by R, E equal to Vs by R. From that, generally this is the constant value, we have to remove this k. To remove the k at t equal to 0, at t equals 0, I of t is become 0, simply inductor flowing through the current is also 0. We will explain this thing. So, finally, I of t is 0, k into e power minus 0 by tau plus Vs by R, you know that what is Vs by R, already we find out I, steady state value or particular solution, that is why I. So, then we can modify k value is nothing but the minus I, k value is nothing but the minus I. Substituting k value in equation 4, this is the equation 4. In this we will substitute the k value. Then I of t is become, in place of k it will become minus I e power minus t by tau plus Vs by R. And finally I of t equal to minus I into e power minus t by tau plus I. From that, current through the inductor, current flowing through the inductor in complete manner, that means it consisting of the transient as well as steady state. Transient, in order to reach the steady state, it will follow the 5 time constants, 5 time constant. Then minus I into e power minus t by tau plus I. From that, IL of t equal, if you common the I, it will become 1 minus e power minus t by tau. The final current value is nothing but I into 1 minus e power tau. This is the current flowing through the inductor, current flowing through the inductor. So from this particular current, particular inductor, the current flowing is, by doing the mathematical things, we will get I means final steady state value or maximum value. 1 minus e power t means at particular time, tau is the time constant, right. Next, we will discuss voltage also. In the time analysis, we will discuss two things, one is current, another one is voltage. Why? Because power consisting of current and voltage only. That is why voltage across L equal to VL of t, L into di by dt. This is the formula of the voltage. Then we will simplify this. Finally, we will get like this, I into L by tau, tau 1 minus e power tau. But for the inductor, the tau value is L by R. Substituting this L by R in this equation, VL of t equal to I into L by tau equal to L by R into e power minus t by tau. By simplifying this, finally we will get I into R e power minus t by tau, right. But I into R is nothing but V. I into R we get nothing but maximum voltage. I into R is nothing but maximum voltage at steady state value. That directly we can write it the source voltage or maximum voltage. Better to write the maximum V, maximum voltage. Better to keep not V as V. V. Here V also V is maximum value, maximum voltage of inductor. Why? Because we are discussing about inductor. That means this is the VL, it consisting of the VL and it consisting of the IL. That IL is nothing but the simply a loop current. Same current in flowing in source voltage, same current in flowing in resistor and same current flowing in the inductor. That is why it is the loop current. But in case of VL, VL is related only the inductor voltage. So maximum voltage of the inductor, right? Steady state value of the inductor. Maximum value or steady state value, both are same. Now the equations will, the voltage and current value, we will reach the voltages and current values. Look at here, this is the voltage of the inductor and this is the current of the inductor. Now it is the important thing. Now the most important thing you have to understand. Right? Look at here. This is, if you draw the graph between inductor current and time t. Time t, I already mentioned, whenever the switch is closed, it's directly become the steady state value. It will reach some time, that time is 5 time constant, 5 time constant. But what is time constant, Jurandi? Look at here, this is 5 time constant. Before the 5 time constant is called it as transient response, that means transient output. After 5 time constant, it is called as steady state response. In our problems up to now, we are discussed in this area only. We are not discussing about this area, but in order to know this area, this analyzing is discussed. This complete analyzation is entering here, right? If you draw the graph between this inductor current and the tau, it will follow the curve like this. It will follow the curve like this. Look at here. This is the current. If you substitute t equals 0, tau, t tau, 3 tau, 5 tau, it will follow this curve. Up to 5 tau, it will reach I value. It will reach I value. Where this is the maximum value or steady state value, this I is maximum value or another name is steady state value of inductor current. For this 67% of this maximum value of the inductor current is known as tau, is time constant. We already mentioned, we already discussed in the time constant definition. The time constant by the diagram is, look at here, 67%. So for the 5 time constant, it will reach the final value. Where it will reach the final value, steady state comes into the picture. After that, it will only fixed value. It will only continues the fixed value. Understand? So simply in RL series circuit, this is RL series circuit. At particular time, if switch is closed, the current is follows this path. The path is it will take some time. After that time, it is fixed. Where the value is constant, this is known as the steady state value. That's why when we are discussing this, at this area, at steady state value, the current is constant. The differentiation of the current with respect to time is 0. From this graph only, right? So that's why this is about a transient region, this is about a steady state region. To reach the steady state, it requires 5 term constants. We are discussing about these things. This is the maximum value, right? Yes, this is about the inductor current. But what about inductor voltage? Inductor voltage formula is V into e power minus t by tau. Here, small t is varied from 0 to tau, 2 tau, 3 tau, 4 tau, 5 tau. Look at here. Actually, it is exponentially decaying. Exponentially decaying means at t equals 0, e power 0 means become V. V means the maximum value. Yet, for this time constant is different for the voltage of the inductor. Voltage of the inductor, 33% is tau. But when we are considering the inductor is related to current, not for voltage. Understand? Why? Because when we are discussing the inductor energy, it is half I square L. That means there is a relation between inductor and current, not voltage. But here also at 33% it will say tau. The change in current at tau it reaches 67%. At tau it will decrease 33%. At 5 tau it will reach maximum value. At 5 tau it will reach 0 value. Understand? That means at this the inductor become as short circuit. We can name it as the inductor become as short circuit because the voltage area is 0. Inductor of the voltage is 0. That's why inductor become short circuit. Understand? From that, finally, at steady state value, inductor is always short circuit. The reason is current is maximum value, high current is flowing and the voltage is 0. Wherever the voltage is 0, it become short circuit. Understand? That's why the note at steady state, inductor become short circuit. Understand? So this is about the important concept regarding the time domain analysis of the RL series circuit. So you have to write each and everything regarding this and you will analyze each and every point. If you have any doubt, you can contact me because up to now topics, this is somewhat difficult topic. We have to require more analyzation. So, for that I will again explain you, but this is about the time domain analysis of the RL series circuit. Once again, what is time domain analysis? Time domain analysis means analyzing the particular element current and voltage with respect to time. Look at here. Here for inductor we are discussing about, if it is RL circuit, but we are discussing about inductor. In this inductor we are discussing about the inductor current and inductor voltage with respect to time. With respect to time. This is the analyzation of the RL series circuit. Okay, thank you.